Okay, hello and welcome. In this video, we are looking at the content and factors and multiples. A very major prerequisite is the fact that your division is very good. All right, so my recommendation would be that if your division is not so good, maybe you take like a week or two to work on division thoroughly. All right, multiplication tables and then division thoroughly before you come back to begin to explore this content. You will do a lot better if you go with that approach. Okay, so let's begin. The first question says express 6 times 15 as a product of prime factors. All right, so that's 6 times 15. I'll just split them. So this would be 2 times 3, and this would be 3 times 5. So I would end up with 2 times 3 times 3 times 5. That's option A. Option A. All right, so one could very well have, first of all, multiplied 2 of them. If you multiply 2 of them first, 6 times 15, you would get 90. And then you can, after doing the prime factorization of 90, you would arrive at the same point. Okay, number 2. The LCM of 4, 10, and 6. The LCM of 4, 10, and 6 is... Okay, so let me do that. 4, 10, and 6. We'll pick up prime numbers and use them to divide. We'll start with 2. 2 in 4 is 2. 2 in 10 is 5. 2 in 6 is 3. I can use 2 again. 2 in 2 is 1. 2 in 5, 2 can't go in 5, so we write 5. 2 in 3 can't go, so we write 3. Now we use 3. 1, put down 5 because 3 cannot go in 5, and then we'll put down 1 here. And finally we use 5, so that we arrive at 1, 1, 1. All right, so the correct answer is 2 times 2 times 3 times 5. 2 times 2 times 3 times 5. That's 60. 60 is the correct answer. Okay. Question 3 says, a number that has only 2 different factors is called a prime number. A prime number is a number that can only be divided by 1 and itself. So those are the 2 factors, 1 and itself. An example of a prime number, you could say maybe 7 or 5. All right, so let's use 7. The only factors of 7, 1 and 7. Those are the only 2 factors. Any number that is not prime, for instance 10, you can always find multiple factors, right? 1 can divide 10, 2 can divide 10, 5 can divide 10, and 10 can divide 10. But if it's a prime number, you would only have two factors. All right, question 4 says, calculate the HCF of 24 and 30. Calculate the HCF of 24 and 30. All right, so for HCF, we only divide by what can divide both of them. I know 2 can divide both of them. Both of them they're even numbers, so 2 can divide both of them. I would have 12 here and I would have 15. 2 cannot divide both of them anymore, so I can't use 2, but I can use 3. Because 3 can divide both of them. I would have 4 and 5. There is nothing else that can work. So my LCM, I need to multiply these guys. That would be 2 times 3, which is 6. 2 times 3, which is 6. Question 5 says, divide the LCM of 4 and 18 by their HCF. I'll find the LCM of 4 and 18 and then find their HCF and then divide it. So let's go. The LCM of 4 and 18 is, I can use 2. I would have 2 and 9. I can use 2 again. 1 and 9. I can use 3, 1 and 3. I can use 3, 1 and 1. My LCM is 2 times 2 times 3 times 3. That's 36. The LCM is 36. HCF. So for HCF, we only use what can divide both of them. All right, so 2 can divide both of them. That would be 2 and 9. And there's nothing else. There is nothing else that can divide, 2 and 9 together. So HCF is 2. So going back to the question, it says divide the LCM. That's the LCM of both of them. The LCM is 36. Divide 36 by their HCF. Their HCF is 2. 36 divided by 2 is 18. 36 divided by 2, 1 remainder 1, 8. 36 divided by 2 is 18. The correct option is option A. Option A. Question 6 says, explain 144 as a product of its prime factors in index form. There are two ways to do this. We can use the regular division. So I'll do both for this question. I'll do the one where I divide, keep on dividing by prime numbers, just like you would do LCM. But I would also do the one where we just split up 144 continuously until we arrive at prime factors. Okay, so I can use 2 because it's a prime number. 2 in 144 is 72. I can use 2 again because it's still an even number, rather, because it's an even number. I can use 2. I can still use 2 because it's an even number. This gives me 36. I can use 2. This gives me 18. I can use 2. This gives me 9. 9 is not an even number, but I can use 3. This gives me 3. And 3 again gives me 1. All right, so the answer to this is 2 times 2 times 2 times 2 times 3 times 3. Or in index form, like they asked for it, you would have 2 raised to the power of 4 times 3 raised to the power of 2. Okay, but now if I want to, I can use the splitting method. So I can split 144 into 12 times 12. But these are not primes, so I can split it further. I can split this further into 3 times 4. So 3 is prime. And I can split 4 further into 2 times 2. They are both prime. Alright, so I'll go on and circle the prime ones. Next, we move on to the other 12. Same process, 3 and 4, because 3 times 4 gives 12. 3 is prime. And then 4, 2 times 2. So what do we end up with? We end up with 4. We have 4 2's, right? So 2 times 2 times 2 times 2, that's 2 raised to the power of 4 times 3 raised to the power of 2. Okay, so you can learn to practice both of them, so that whichever one is easier for you, you just run with it. All right, the answer is 2 raised to the power of 4 times 3 raised to the power of 2. That's D. Okay, moving on. We have question 7. All right, so for this question 7, I'm just going to do the splitting method here. 900. Let's split 900. I will get 30 times 30. Or you could use 100 times 9, whatever works. I can split 30 up. I will get 3 times 10. 3 is a prime number, so I'll circle 3. I can split up 10. I would now have 2 times 5. And 2 and 5 are prime, so I'll circle them. Same process here. I would have 3 times 10. Split up 10. I would have 2 times 5. That means that the answer is going to be 2 raised to the power of 2 times 3 raised to the power of 2 times 5 raised to the power of 2. 3 raised to the power of 2 times 3 raised to the power of 2 times, that's D. D, good. Question 8 says, express the LCM in prime numbers. Express the LCM in prime numbers. Okay, let's do that. So LCM of 50 is probably going to be quite long. 50, 18, and 32. 50, 18, 32. I can go on and start with 2. I would have 25, I would have 9, and I would have 16. I can still keep using 2 because of 16. So 2, 25, 9, and 8. 2, 25, 9, and 4. 2, 25, 9, and 2. 2, 25, 9, and 1. So I'm done with 2. I think I move on to 3 now because 9. So 25, 3, and 1. 3, 25, 1, 1. Now I can move on to 5. 5, 1, 1. And finally 1, 1, 1. So this is a lot. So the answer is 2 raised to the power of how many? 1, 2, 3, 4, 5. So 2 times 2 in 5 places. That's 2 raised to the power of 5 times 3 raised to the power of 2 times 5 raised to the power of 2. We are looking at option. D. All right, so find the LCM of 4, 6, and 20. 4, 6, and 20. And express that LCM as a product of prime factors. So 4, 6, 20. We can use 2. We have 2. We have 3. We have 10. We can use 2 again. We have 1. We have 3. We have 5. Now we use 3. We have 1, 1, 5. And finally, we can use 5, 1, 1, 1. So the answer is 2 times 2 times 3 times 5. 2 times 2 times 3 times 5. Okay, finally number 10. Express the LCM of 8, 12, and 30. Okay, 8, 12, and 30. 8, 12, and 30. Okay, so we can use 2, 4, 6, 15. Pick up 2 again. 2, 3, 15. 2 again. 1, 3, 15. Now we can move on to 3. 1, 1, 5. And then 5, 1, 1, 1. We have 2 raised to the power of, okay, or 2 times 2 times 2 times 3 times 5. That option is option E. Option E, that's the correct option. Question 11 says, express 270 as a product of prime factors. So let's use the splitting method. 270. This would be 27 times 10. All right, so I can split up 27 into 3 times 9, and then split up 9 into 3 times 3. These are all prime numbers. I can split up 10 into 2 times 5. So the answer is going to be 2 times 3 times 3 times 3 times 5. 2 times 3 times 3 times 3 times 5. That's option D. So the same question is repeated. All right, so that's 2 times 2 times 2 times 3 times 3 times 3 times 5. That's B. Okay, good. Express 90 as a product of prime numbers. Okay, let's do that. So 90 would just be 9 times 10. 9 splits up to 3 times 3. 10 splits up to 2 times 5. And these are all prime numbers, so we're good. So it is 2 times 3 raised to the power of 2 times 5. 2 times 3 raised to the power of 2 times 5. That's option E. 2 times 3 times 3 times 5. Okay, 14 says, find by factors the square root of 576. Find by factors the square root of 576. I will keep 576 here. Let me start with 2. 2 in 576. This will give me 288. And then can still use 2. So 2 in 288 gives me 144. And we still work with 2. 2 in 144 gives me 72. Still work with 2. This gives me 36. We can still work with 2. This gives me 18. We can still work with 2. This gives me 9. Can still now work with 3. This gives me 3. And finally 3, this gives me 1. All right, so when we're dealing with square root, we pick them up in pairs. All right, because it's square root, so we just pick them up in pairs. If it's a perfect square, then the factorization will be able to pop up in twos. We'll be able to split into twos. All right, so for each factor, you'll be able to, take them in pairs if it's a perfect square. If we're working with cube roots, if the question was cube roots, then we would have had to take them in threes. All right, would have had to take them in threes. Okay, so it's square root, so taking them in pairs, so we'll pick up 2 here, 2 here, 2 here, and 3. The final answer, we just multiply this now. 2 times 2 is 4, 4 times 2 is 8, and 8 times 3 is 24. So the correct answer is D, 24D. All right, 15 says, find the cube root of that. Okay, good. Find the cube root of that. So I have one whole number, 91 over 125. I can write it as an improper fraction. All right, so it's just going to be 125 times 1 plus 91. So 125 plus 91 will give me 216. So this is actually 216 over 125. So the first thing you do is you write as an improper fraction. Now we can now take the cube root. We have to take the cube root, so we can take the cube root now. We'll take the cube root of the top and then the cube root of the bottom. This will just be cube root of 216 over the cube root of what? Cube root of 125. Okay, so let me put that down nicely. The cube root of 216 over the cube root of 125. Okay, so let's begin. 216. Let's see if we can find the cube root. 216, we can use 2. This will give me 1, 0, 8. We can use 2 again, this gives me 54. We can use 2 again, this gives me 27. Now we'll move on to 3, 9, 3, 3, 3, 1. All right, so that means that we have, since it's cube root, we take them in threes. If it was square root, we would have taken them in twos, but it's cube root, so just pick the first group of 3, the next group of 3. So we have 2 times 3. That means that the cube root of 216 is 6. 2 times 3 is 6. Over, let's take let's now solve for the cube root of the bottom. Let's solve for the cube root of 125. 125. All right, so I could use 5. This would give me 25. 5, this would give me 5. And then 5, 1. All right, so the cube root we have here, we check group of 3, right? So it's just 5. So this means it's 6 over 5, which you can write as a mixed number as one whole number, 1 out of 5. one whole number, 1 out of 5. So the steps to find the cube root or square root of a mixed fraction or mixed number is, you first of all write it as an improper fraction. All right, then you apply the roots to both the top and the bottom and then simplify. That's all. All right, so the answer is A. Find the cube root of 2744. Wow. Okay, let's begin. I'm still going to go down the route of prime factorization, but another thing you could do is you could multiply. Like, for instance, I can solve for 9 cube and solve for 12 cube and solve for 14 cube and solve for 15 cube and solve for 18 cube. All right, and that thing that you could do is you could eliminate. So I know it can be 9, because 9 times 9 is just 81. If I multiply 81 by 9, I can get up to 900, so it's obviously wrong. All right, I know it can be 15, because if it's 15, 15 times 15 times 15, you know, the number at the end would always be 5. All right, so it obviously cannot be 15. So I think we should try, if I were to try, I will attempt 18 first, or 14. Another thing you could do is just multiply the last digits, the 2, 3 times, and see if the last digit you have is this. All right. So for instance, if I do 12 times 12, I would have 144, right? So when I times it by 12 again, when I multiply it by 12 again, 2 times 4 would give me 8. That's going to be the last digit, so it's obviously not 12. All right. And then 14, 4 times 4 is 16. 16 times 4 ends with 64. All right, so 14 is probably the culprit here. 18, 8 times 8 is 64. 64 times 8 ends with 32. So the answer is C14. The answer has to be C14. But then let's just do the regular, the regular prime factorization thingy and see where we end up. All right, so we have 2744. All right, I could work with 2, so I have 1, 3, remainder 1, 7, 2. I could work with 2 again. I would have, so in 13 will give me 6, 8, 6. Could work with 2 again. I would have 3, 4, 3. All right, so 2 doesn't work, obviously. 3 doesn't work because if we get the sum of the digits, it's not going to give you a number that can be divided by 3 to give you 10, which cannot be divided by 3. So that means the number itself cannot be divided by 3. The next prime number is 5. Well, 5 obviously wouldn't work because it doesn't end with 5 or 0. So I guess we try 7. So 7 in 34 would be 4 times. 4 remainder 6. 7 is 63 is 9. We can work with 7 again. We get 7. And then work with 7. We have 1. All right. So when I group them in, all right, I get 2 times 7, which is 14. Okay. So in all honesty, if I were to attempt this question in an exam, I think that going by, sorry, this was supposed to be 2 here. Thank you. So I think that going by just checking by trial and error would probably have been faster, and I didn't have to multiply the whole thing. But either way is fine. So the correct option is C, 14. Okay, so find the cube root of 27. I mean, I don't think we need to calculate this, right? It's 3, because that's 3 times 3 times 3 is 27. Right, so that's the only number that can do that. But you can do the prime factorization, you just get 3. Okay. This says find the difference between the LCM of 21 and 28. So we need to solve for that. And the HCF of 18 and 45. And we need to solve for that. Difference means we subtract. Okay, so let's do that. The first thing is let's find the LCM. The LCM of 21 and 28. We can use 2. 2 in 21 cannot go, right? 21, but 2 in 28 would give me 14. 2 cannot go. This will give me 7. I can use 3, 7, 7, and I can use 7, 1, 1. So my LCM is 2 times 2 times 3 times 7. All right, so I'll multiply backwards because I don't want to deal with multiplying by 7. Okay, it's just, okay, so 12 times 7 is 84. All right, so the answer is 84. The LCM of both of them is 84. Next, we do HCF. All right, so the HCF of 18 and 45. For HCF, we only divide by what can divide both of them. So we can't use 2, but we can use 3. This would give me 6, and this would give me 15. I can use 3 again. This would give me 2, and this would give me 5. So there's nothing else that can divide both of them. So my HCF is just, sorry, this is the LCM that I got. Okay. Then my HCF is 3 times 3 times 3 from here, which is 9. All right, so the LCM is going to be, this is going to be 84 minus 9. All right, so the LCM is 84, the HCF is 9. We subtract that, and I will expect that we get 75. We get 75. Correct option is A. 75A. Okay, find the HCF of 40, 24, and 60. HCF will only divide by what can divide all of them. So 40, 24, and 60. We can work with 2. I have 20, I have 12, I have 30. I can work with 2 again. I have 10, I have 6, we have 15. There's nothing else that can divide everything. All right, so the answer is just 4. 2 can divide everything, 3 can divide everything. So the answer is 4. Okay, find the HCF of, let me just erase the, okay, so find the HCF of 12, 18, and 36. We can use 2. This gives me 6, 9, and 18. All right, now we can use 3. This gives me 2. This gives me 3. This gives me 6. All right, so there's nothing I can divide through anymore, right? So for HCF, remember, we only divide by what can divide everything. So 2 times 3 is 6. The correct option is 6. Okay, find the HCF again. So find the HCF of 40, 24, 40, 24, and 60. We can use 2, 20, 12, and 30. We can use 2, 10, 6, and 15. Okay, the answer is 4, right? Because there's nothing else that can divide all of them. So the answer is 4. 2 times 2, 4, right? So we got 4 because we multiplied 2 by 2. And when we are doing HCF, remember, we only divide by what can divide everything. Okay, we find the HCF of 26, 65, and 91. 26, 65, and 91. All right, so the only thing that can divide all of them is 13. All right, the only thing that can divide all of them is 13. So we have 2, 5, and 7. There's nothing else that can work. All right, so I know for this question, it might have been a bit interesting because you might not have known, I mean, people don't learn their 13 multiplication tables and all of that. But then if you see 26, I feel like we should be familiar enough to know that 2 times 13 is 26. All right, and then just look at the option. All right, so it's you can also do this by elimination. Okay, so let's move on. Find the HCF of 15, 18, and 24. All right, so find the HCF of 15, 18, and 24. So if you think that we don't have to draw this table for this question, you're right. All right, because we really are just being asked for the biggest number that can divide all of them. all right? And we know it has to be 3, all right? So that's because that's even the only number that can divide all of them. So this will give me, okay, well, 3 and 1, but obviously 3 is more than 1. So we're looking for the highest, right? So 3 in 15 is 5, 3 in 18 is 6, 3 in 24 is 8. So the answer is D, 3. Find the HCF of these two factors. So they gave it to us in index form. All right, they gave it to us in index form, and we asked to find the HCF. Okay, good. So let me quickly teach this, right? If you're given a question in index form and you're asked to find the HCF, then you look for the overlap. What can you find in both of them? All right, that becomes your answer. But if you're asked for the LCM, then you look for the, the whole thing put together, but you don't repeat. All right, so for this question, I'm going to solve for both the LCM and the HCF. All right, so let's start with HCF because that's what they asked us for. So for HCF, my thinking is the overlap of both of them, right? So there's 2 here, but there's no 2 here, so I don't add 2. All right, there's 3 here, but then the 3 here is double, but there's only 1 3 here, so I just take 1 3. All right, because that's what you can find in both of them. You can find at least 1 3. All right, at least 1 3. For 5, we have 5 squared in both of them, so we can find at least 5 squared. And then 7, we can find just 1 7, at least 1 7. So this is my HCF, which is option E. All right, but if I was asked for the LCM, we'll look for the combination without repetition. So you can say at most, what can I find? All right, so at most I can find 1 2. At most I can find 3 squared. At most I can find 5 squared, and at most I can find 7 squared. So that's the LCM. All right, so for LCM, we look for at most, or if I combine it, what can I find? What's there in both of them. So if it occurs in only one, I still put it in. All right, but for HCF, we look for at least. All right, so let me write this. For LCM, we look for at most. For HCF, we look for at least. That's when you have it in this, in this exponent form. But the correct answer for HCF is E. Is E. All right, so moving on. Okay, so same thing here. Find the HCF of this, right? Okay, so we have 2 squared times 3 cubed times 5. So if you missed this question, my recommendation is that you go back and watch the video just before this one. So just go back just a tiny bit, all right? And then you can see, the way I solved, because for the other one I did for both LCM and HCF when you have them in this form. All right, so we have 2 squared, 3 cubed, and 5. And then we have 2 squared times 3 squared. All right, so if we're doing HCF, we look for what we can find in both of them, okay? The overlap. All right, you pick up only what we can find in both of them. So at least, how much can you find? At least. So when it comes to 2, at least I can find 2 squared. All right, and then when it comes to 3, at least I can find 3 squared. All right, because this is more than I need, but at least I can find 3 squared. So by comparison, and then for 5, well, at least I can find nothing. All right, so there's the other one has no 5, so I might as well not pick up any 5. So this is going to be 4 times 9, which is 36. 4 times 9, which is 36. All right, 26 says we should find the HCF of 96, 120, and 144. So we have 96, 120, and 144. So 96, 120, 144. All right, so we start with 2. We start with 2. 2 in 96 is 48. 2 in 120 is 60. 2 in 144 is 72. We can use 2 again. 2 in 48 is 24. 2 in 60 is 30. 2 in 72 is 36. All right. We can use 2 again. Remember, we're doing HCF, not LCM. So we're only dividing by what can divide everything. All right. So 2 in 24 gives me 12, 15, 18. And I can use 3. All right. So 3 in 12 is 6, 5, 6. Oops, sorry, 3 in 12 is 4, my bad. All right, 3 in 12 is 4. Okay, but it's fine because nothing else can divide. So the correct answer is 2 times 2 times 2 times 3, which is 24e. 2 times 2 times 2 times 3, which is 24e. Okay, so let me just put that down here. 2 times 2 times 2 times 3, 24. All right, we multiply the numbers that we use to divide. The prime factors, we multiply them out. Okay, so for 27, tick, 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 tick. 27, we have find the HCF of 168 and 189. 168 and 189. Okay, so for me, I feel like I would just want to find out what can divide, both these numbers. All right, and I mean, I just saw a nice little trick, 21. So I mean, if you look here, divide, like 16 is okay. So 21, 2 is double of 1. Okay, so 16 is double of 8. Okay, and then with 189, so it's same thing, right? So I mean, it's easy to see, all right, that it's 21. All right, 21 can divide, at least divide both of them. All right, but let's do the regular way. So let's do the HCF. We have 189 and 168. 168 and 189. I can use 3. We only use what can divide all of it, right? So I can use 3. And why am I using 3? Because 2 cannot work. And 3 because the divisibility rule for 3 is that the sum of the digits can be divided by 3. So if you add 1, 6, and 8, you get 15. 15 can be divided by 3. If you add 1, 8, and 9, you get 18, which can also be divided by 3. All right, so that means 3 can work. So if I divide by 3, I would have 5 and put the 1 here, and then 5 in 18 is 6. Good. If I divide here by 3, I would have 6 to 3. All right, so what can divide both of them is 7. 7 here gives me 8 and 9. So my HCF is just 3 times 7, which is 21. My HCF is just 3 times 7, which is 21. Okay, moving on to 28. Find the highest common factor of the numbers. All right, the highest common factor. So again, we can do this, off the top of our head, because HCF simply means the highest number that can divide all of them. All right, so we know 2 can divide all of them, 4 can divide all of them, 8 can divide all of them, right? So it really depends on how intuitive you are with your multiplication tables. If you're very intuitive with your multiplication tables, you can do this without actually calculating. Yeah, so working with this, but I mean, so the answer is 8, obviously, right? But let's just do the math. HCF 16, 32, 40. 2 in 16 is 8, 16, 20. We can still use 2, 4, 8, 10. And finally, we can use 2, 2, 4, 5. So we can't use 2 anymore, right? Because nothing can divide through, all right? Nothing can divide through. So it's just 2 times 2 times 2. 2 times 2 times 2, which is 8. 2 times 2 times 2, which is 8. Sorry, I didn't select that. That's 8. Number 60. Find the highest common factor of all of that. All right, so I know 2 works. I know 3 works. 6 works. 12 doesn't. So the correct answer is 6. Okay, so I just picked the options and then I try to use each of them to divide through. All right, and so the highest one I could get, the highest factor that is common to all of them is 6. All right, but then we would always, of course, still do the table method. And we know we just divide by what can divide all of them. So we have 12, 30, 42 and 72. Let me make my lines nice. Okay. Okay, so we can use 2. We have 6, 15, 21, and 36. All right, we can't use 2 anymore, right? But we can use 3. All of them are divisible by 3. So we have 2, 5, 7, and 12. All right, so there's nothing we can use to divide all of them anymore. So HCF is simply what? 2 times 3, which is 6. 2 times 3, which is 6. Okay. Find the highest common factor of 12, 15, and 24. Find the highest common factor of 12, 15, and 24. So again, we can do this in our head, because if you look at it, you know that the biggest number that can divide all of them should be 3. All right, nothing else. Nothing else can divide all of them. But let's just do the math. 15 and 24. Of course, we use 3, 4, 5, 8, and there's nothing that can divide the next group. So your HCF is just 3. All right. Remember, for HCF, we are dividing by what can divide all of them. All right. We divide by what can divide all of them. All right. Okay. Find the LCM of 2, 3, 5, and 7. Find the LCM of 2, 3, 5, and 7. Okay, so if you think about it, right, the LCM of this would just have to be the product of all of them, because they are all prime numbers. That means that there is you can't find anything that can divide any of them, that can divide more than one of them. All right, you can't find anything that can divide more than one of them. But let's work. So we use 2, 1. We bring down 3, 5, 7, because 2 can't divide any of them. We move on to 3, 1, 1, 5, 7. We move on to 5. We have 1, 1, 1, 7, and we pick up 7, 1, 1, 1, 1. So it is 2 times 3 times 5 times 7 for the LCM. 2 times 3 times 5 times 7. That's 6 times 5 is 30. 30 times 7 is 210. Right. So the LCM is 210. Oops. Let me just write that. 210. All right, 210, that's option E. Okay, hold on, let me just go back and check why these questions are unanswered. Let me just confirm that we did them. 22. 22 was 13, right? I forgot to select the answer. And then 27. 27 was 21, yes, right? 30. 30 was 3. Yeah, 3. That's HCM, right? Yes. 30 was 3. Okay. So let's move on. 32. Find the LCM of 14 and 18. Find the LCM of 14 and 18. 14, 18. All right, we can use 2. We have 7 and 9. We can use 3, we have 7 and 3. We can use 3, we have 7 and 1. We can use 7, we have 1, 1. Okay, so those are the prime numbers you can use. Begin to multiply. That gives me 21 times 3 is, I'm multiplying backwards, all right, because I don't want to deal with multiplying by 7, if I come down that way. So 7 times 3 is 21. 21 times 3 is 63. 63 times 2 is 126. So if you have big factors, all right, it's easier to multiply backwards. All right, so 7 times 3 is 21. 21 times 3 is 63. 63 times 2 is 126. Okay, good. So it's easier to multiply backwards. if you have big numbers at the end. Okay, so this is all right. Question 33 says, find the LCM of 18, 18, 27, and 36. All right, so we can use 2. 2 in 18 is 9. 2 in 27, just put down 27. 2 in 36 is 18. We can still use 2 again. 9, 27, 9. Now we move on to 3, 3, 9, 3. Move on to still use 3, 1, 3, 1. Finally, 3 goes 1, 1, 1. So we have our LCM as 2 times 2 times 3 times 3 times 3. 2 times 2 is 4, 4 times 3 is 12, 12 times 3 is 36, 36 times 3 is 108. 36 times 3 is 108. 36 times 3 is 108. All right, find the LCM of 48, 40, and 24. Find the LCM of 48. All right, so I'll take 2. 2 in 48 gives me 24, 20, and 2 in 24 gives me 12. All right, you can still use 2 again. This gives me 12, 10, and 12, 10, and what? And 6. Good. I can use 2. I have 6, 5, and 3. I can use 2. I have 3, 5, 3. I can use 3. I have 1, 5, 1. And then I use 5. I have 1, 1, 1. Okay. So for this one, I think I'll multiply, from down up, so that because the number might be big, right? So 15 times 3 is 5 times 3 is 15, times 2 is 30, times 2 is 60, times 2 is 120, times 2 is 240. All right, so 240 is correct. That's option A. So when I notice that I might have like the numbers are big, right, it's probably easier, it's easier for me to start to multiply from the bottom and work my way up. All right, next question. Oh, it's the same. Bonus, 240. Okay, find the LCM of 12, 15, and 18. Find the LCM of 12, 15, and 18. Right, so find the LCM of 12. All right, so I can use 2. I would have 6. I'll have 15, and I'll have 9. Okay, so we put down 15 because 2 can't divide 15, right? I will use 2 again. I'll have 3, 15, still put down 9. Now I can move on to 3 because nothing can divide 2, can be divided by 2 anymore. I'll have 1, 5, 3. I'll use 3 again. I'll have 1, 5, 1, and then 5, and I'll have 1, 1, 1. All right, so my LCM is just a case of multiplying all of them, right? All the factors, which would be 2 times 2 times 3 times 3 times 5. 2 times 2 is 4, 4 times 3 is 12, 12 times 3 is 36, 36 times 5 is 360. Okay, so let me do that again. 2 times 2 is 4, 4 times 3 is 12, 12 times 3 is 36. Oh, 36 times 5 is 180. So the answer is 180. Ooh. B. All right, find the LCM of 12, 18, and 24. basically what's the smallest number that all of these numbers can divide. 12, 18, and 24. All right, so 2, we have 6, we have 9, we have 12. We can use 2 again. 3, 9, 6. Our LCM, we have 3 would be 9, 2 times 2 times 2 times 3 times 3. Now we can use this would be 8, 1 for this 3 here, 1, and finally times 9, 1, 1, 1. Right? All right, so we end up with 72. So the answer is 72. 72 is A. Okay, 38 says find the LCM of 15 and 24. LCM of 15 and 24. All right, so I can use 2. All right, this will give me 15, but then here would be what? 2 in 24 would be 12. 2 in 15, oh, we still write down 15, but this gives us 6. We use 2 again, 2 in 15, we write down 15, but now we have 3, all right? 2 in 6 is 3. Next, we use 3. We have 5, 1, and now 5, we have 1, 1. All right, so the LCM is 2 times 2 times 2 times 3 times 5. This is 8 times 3 times 5. 24 times 5, which is, oops, 24 times 5, right? Which should be 120. So 120 is the LCM of 15 and 24. All right, so question 39 says find the LCM of 165 and 210. All right, so the LCM of 165, 165 and 210. Let me write that 165 nicely. All right, so 165. Okay, so we could use 2, right? Because of 210 is an even number. So 2 in 165, we just put down 165. 2 in 210, we have 105. All right, then now we can use 5. All right, we can actually use 3 because if we use the check divisibility rule, 3 works. All right, so let me go back and do it in order. If we check the divisibility rule, for 165, 1 plus 6 plus 5 is 12, and 12 can be divided by 3, right? So that means that the number can be divided by 3. If we check for 105, 1 plus 0 plus 5 gives you 6, all right? And 6 can be divided by 3. So yes, so 3 works. So let's work with 3. So 3 in this would give me 5, remainder 1. So 3 in 15 is 55. And then 3 in 105 is 35. All right, 3 in 105 is 35. All right, so next we use 5. I can use 5. 5 in 55 is 11. All right, 5 in 35 is 7. Next I can use 7. 7 here is 11. And 7 in 11 cannot go, so rather, so you write 11. But 7 in 7 is 1. All right, next I use 11. 1, 1. Okay, so we have 2 times 3 times 5 times 7 times 11. All right, as the solution. So 2 times 3 is 6. 6 times 5 is 30. 30 times 7 is 210. 210 times 11. Wow, this is a big one. So 210 times 11. So give me 210. All right, 1 times that, and then this will give me, 210 again. So we add it up. We have 0, 1, 3, 2. So it's 2,310. 2,310 is correct. Okay, find the least common multiple, LCM of 8, 12, and 18. Okay, I feel like we've done this question before, but find the least common multiple of 8, 12, and 18. So 8, 12, and 18. What can I use? I can use 2. 2 in 8 is 4, right? 6 and 9. can still use 2, 2, 3, 9. Still use 2, 1, 3, 9. Because 2 can divide them, right? So we'll just write them down. 3, 1, 1, 3. Finally, 3, 1, 1, 1. So we have 2 times 2 times 2 times 3 times 9, which gives you 72. All right, I'm not sure what I said, but it's 72. So that will be 2 times 2 times 2 times 3 times 3. That's 8 times 9, which is 72. All right, so 72 is the correct answer. Well done. All right, next. Okay, so 41 says, find the least number that can be divided by 9, 7, and 6, leaving the remainder of 1 in each case. Okay, so you think about this, and if we take the question just this, up until this point, it's obvious that you're finding the lowest common multiple, the LCM, right? So what you want to do is you want to find the LCM and then add the remainder. All right, add the remainder. So the LCM will give you the least number that can be divided by 3 of them. So you then just add the remainder so that when you divide by any of them, you would have that remainder, So let's find the LCM and then we'll add 1. So that'll be the LCM of 9, 7, and 6. We can use 2. Twin 9 doesn't work, so we'll put down 9. Twin 7, we'll put down 7. Twin 6, 3. We can use 3 now. We have 3, 7, 1. We can go again with 3, 1, 7, 1. And then now we go with 7, 1, 1, 1. So the answer is 2 times 3 times 3 times 7. That's 6 times 3, 18. 18 times 7 is 126. Right, so the LCM itself is 126. 126. So now we just include the remainder. We just include the remainder that we need, which is 1. So the answer would be 126, which is the LCM, plus the remainder of 1 we need in each case, giving us 127. 127, that's option B. Okay, find the lowest common multiple of 24, 36, and 19. Find the lowest common multiple of 24, 36, and 19. Okay, so we can work with 2. I would have 12, here 18, here 45. We can work with 2 again. We would have 6, 9, and then bring down 45. We can work with 2 again. We'll have 3, 9, 45. Now we'll move to 3, 1, 3, 15. We can work with 3 again. 1, 1, 5. And then finally, we can work with 5. We'll have 1, 1, 1. So the LCM is 2 times 2 times 2 times 3 times 3 times 5. Multiplying that out from the back, 15, 45, 90, 180, and then 360. So the answer is 360C. The answer is 360C. So the LCM is 316. Okay. Find the smallest number that can be divided by 6, 5, and 4. Again, that's speaking about the LCM. So find the smallest number that can be divided by 6, 5, and 4. We can work with 2. 2 in 6 is 3. 2 in 5 doesn't work. We'll put on 5. 2 in 4 is 2. We can work with 2 again. We'll bring down 3, 5, and then 1. So we're done with 2. We pick up 3. 3 and 3 is 1. 3 and 5, well, it doesn't work. We'll put down 5. 3 and 1, put down 1. And then finally 5, 1, 1, 1. So the LCM is 2 times 2 times 3 times 5, which is going to give me 16. So the smallest number that all of those can divide is 16. Alright, find the square root of 576, giving your answer in index form. Okay, so we do this, let me do this here, 576. So I can start with 2. We just prime factorize and then, take them out, take them in pairs because it's square root, right? So this would give me 288. We can work with 2 again. This would give me 144. We can work with 2 again. This would give me 72. Can work with 2 again. This would give me 36. Can work with 2 again. This gives me 18. Can work with 2 again. This gives me 9. Now we switch to 3. Work with 3. This gives me 3. And then 3 again. This gives me 1. Alright, so we've divided consistently by the prime factors, and what we actually have there is now the prime factorization, but that's not what we're asked for. We're asked for the square root, so we'll take the prime factorization of the prime factors and then pick them up in 2s, again because it's square root. If it was cube root, we would have taken them up in 3s, so that would be 2, here will be 2, here will be 2, here will be 3, right? So for each group of 2 you create, you pick out, one of the values. We multiply this out for the square root, and we would have 2 raised to the power of 3 times 3. 2 raised to the power of 3 times 3. So that's option B. Okay. All right, what is the square root of 1 whole number 7/9? So we need to find the square root of that. So the first thing we do is we want to rewrite it as a mixed, at an improper fraction here. That will be 9 times 1 is 9 plus 7, that's 16. So 16/9. 16/9. Okay, so to find the square root, it's just going to be square root of 16 over square root of 9, which gives me 4/3. All right, 4/3 can be written as 1 whole number. So 3 and 4 is 1, remainder 1/3. So 1 whole number 1/3 is the correct answer. 1 whole number 1/3. So to find the square root, if you have a mixed number, write it as an improper fraction. Then find the square root of the top and the square root of the bottom, and then just simplify it. All right, so that's for that question. Next we have, okay, so similar question now, which is brilliant. So we can try this one again. We need the square root of 13 whole number 4/9. Okay, 13 whole number 4/9. The first thing we do is we want to rewrite it as an improper fraction. So 9 times 13 plus 4 will give you the number on top, the numerator. 9 times 13 would be, well, that's 9 times 12 when you add another 9. So 9 times 12 is 108. If I add 9 to that, I have 117. All right, so 9 times 13 is 117. 117 plus 4 is 121. All right, so square root of 121/9, which we said would be square root of 121 over square root of 9. Okay, so we end up with 11/3, which can be written as 3 whole number 1/3. So 3 whole number 1/3. That's option C. Sorry, 3 whole number 2/3. Okay, so whoever spotted that, thank you. 3 whole number, because 3 in 11 is 3 times, which, 9. All right, so 3 times, remainder 2. There's a remainder of 2, then out of 3. Okay. 3 whole number, 2 out of 3, that's 46. 47 says find the square root of 625. Okay. So we'll walk through the process. 625. 5 can divide that. 5 in 625 will give you 1, 2, 5. 125. We can use 5 again, would have 25. We can use 5 again, would have 5. We can use 5 finally and would have 1. All right, so since we're doing square root, we pick them out in pairs. We do the prime factorization, then we'll pick them out in pairs. So we have 5 here and 5 here. So the square root is just the product. 5 times 5 is 25. All right, 48 says we should find that value. Find the value of 2 raised to the power of 2 times 3 raised to the power of 2 times 5 raised to the power of 2. So this is 4 times 3 raised to the power of 2 is 9 times 25. So this is 36 times 25. All right, so let's do the math. 36 times 25. Would give me, so this is 30, 0, carry 3, 15, 15 plus 3 is 18. And close out this point here. Then this gives me, next we move on to 2, 2 times 6 is 12, carry 1, 6 plus 1, 7. Okay, so we can add this up. 0 plus nothing is 0. 8 plus 2 is 10, carry 1, 9. So the answer is 900. The answer is 900D. Okay, so there is actually another method, another way we could have solved it, right? So let's look at that. Because we have 2 times 3 times 5, okay, so all of it squared. We can rewrite it as 2 times 3 times 5 all squared. Right, because there's square on each of them. So this is one of the laws of indices. So over time we'll probably do that. So I'm just showing it a different method if you might find this easier. So this is going to be 30 raised to the power of 2, and 30 raised to the power of 2 is 900. Right, so some people might have found this approach easier. Okay. Next we have question 49. It says, how many prime numbers are in the set below? Okay, so we define prime numbers as numbers that can only be divided by themselves and 1. They can't be divided by any other number. So what I'll do is, if we can think of any other number that can divide that number, I'll just strike it out. All right. Okay, let's begin. So 12, yeah, I mean, too many numbers can divide 12. 3, 2, 6, 4. So we strike out 12. 13, nothing can divide 13. Apart from 1 and 13. 14, 2 and 7, so we strike it off. 15, 3 and 5. 16, 2, 4, 8, can divide 16. 17, okay, nothing else can divide 17, so it's a prime number. 18, 2, 3, 6, 9, can divide 18, so 17, 19, nothing else can divide 19. And of course 20, 2, 5, 4, 10, can divide 20. So we have 3 prime numbers. We have 13, 17, and 9. That makes the correct option A. Option A. Okay, number 50. One part of a factor pair is 407. What is the other factor? All right, a factor pair basically just means 2 numbers that you can multiply to get, the number you're trying to factorize. So just Let's do an example. For instance, if we had to list out the factor pairs for 12, all right, it's going to be, I would say 1 and 12, I would say 2 and 6, and I would say 3 and 4. So each of these are factor pairs because they each multiply to give you 12. So if you have only one factor of the pair, you want to find the other one, all you have to do is just divide. All right, just divide. So we're going to just divide 407 by 11. So 11 in 40 would give me 3, remain the 7. Put it here, we have 77. 11 in 77 gives me 7. So the answer is 37. That's option B. Okay, 51 says list the prime factors of 12. Okay, so the factors of 12, we'll just list out the factors of 12, and of the factors of 12, which ones are prime. So factors of 12, we have, if we use factor pairs, we have 1 and 12, we have 2 and 6, we have 3 and 4. Okay, so of this now, which are prime, which are the prime factors, 1 is not a prime number, because, you know, for it to be a prime number, you must be able to be divided by 2 numbers, right? You must have 2 factors, but 1 has only 1 factor, which is 1. So 1 is not a prime number. 12 is not a prime number because other numbers can divide it. 2, 3, in fact, you know, there are a lot of them. 6 is not a prime number because other numbers can divide it, and 4 is not a prime number because 2 can divide it. So we just have 2 and 3. That's option B. Option B, 2 and 3. 52, we have, okay, look at the following numbers. Which of them is not a prime number? All right, so that will be 9. That will be 9 because 9 can be divided by 3, right? So 9 is not a prime number. Okay, so this is to multiply the LCM of 4, 8, and 12 by its HCF. We would have to first of all find the LCM first. So let's find the LCM of 4, 8, and 12. 4, 8, and 12. Then we'll find the HCF. Okay, so LCM, we can start with 2. This will give me 2, 4, 6. We can work with 2 again. We'll have 1, 2, 3. We can work with 2. We have 1, 1, 3. And finally, we can work with 3, rather. We can work with 3 and we'll have 1, 1, 1. Okay, so the answer is the LCM would be 2 times 2 times 2 times 3, which is 8 times 3, which is 24. Which is 24. That's the LCM. Next, we need to find the highest common factor. For the highest common factor, working through the same process, we have 4, 8, 12. Okay, so let's begin. We can divide this by, so for HCF, you can only divide by what can divide everything, right? So we can use 2. 2 in 4 is 2, 2 in 8 is 4, 2 in 12 is 6. And 2 can divide everything again, so we have 1, 2, and 3. All right, so there's nothing else that can divide that, right? So your HCF is just 2 times 2, which is 4. Okay, so the question says multiply the LCM of 4, 8, and 12 by the HCF. So the LCM is 24. We need to multiply that by 4. 24 times 4. 4 times 4 is 16. Put 1 up. 4 times 2 is 8 plus 1, that gives 9. All right, so the answer is 96. 96. Okay, so subtract the HCF of 9, 8, and 12 from the LCM of 16 and 2. Subtract the HCF of 9, 18, and 27 from the LCM of 16 and 2. Okay, let's find the HCF first. Nine, 18, 27. The HCF would be, we can only divide by what can divide everything, right? When you're working with HCF. So we use 3. This will give me 3. This will give me 6. This will give me 9. 3 can also divide everything. So we have 1, 2, 3. There's nothing else that can divide the entire group. So the HCF is just 3 times 3, which is 9. For LCM, we have 16 and 2. So let's find the LCM of 16 and 2. All right, so we can use 2. We'll have 8, 1. We can use 2. We'll have 4, 1. We can use 2. We have 2, 1. We can use 2. We have 1, 1. So LCM would be 2 times 2 times 2 times 2 times 2, which gives 16. All right, so the question is subtract the HCF of that. So the HCF of that is 9, and the LCM of this is from the LCM of that, which is 16. So just simply saying subtract 9 from 16. All right, so 16 minus 9 gives you 7. Correct answer is E. Okay, the factors of 196 are, to ensure that you list out everything, it's best you work with factor pairs so that you don't lose out on anyone. So here's what I mean. A factor pair is a pair of numbers that multiply to give you the number, the other number, right? Like the number you're trying to find the factor pairs of. So if I have to find the factor pairs of 30, for instance, I know, since I know 1 is a factor, I have to go 1 and 30. Since I know that 2 is a factor of 30, I'll then go 2 and 15. The idea is that you might have forgotten 15 if you didn't, but remember 2. So it limits your chances of forgetting any of the factors if you use factor pairs. All right, so let's go with 196. 196. I know it can be divided by 1, so that would be 1 and 96, and 196. I know it can be divided by 2 because it's an even number, right? So that has to be 2 and what now? 2 and, so 196 divided by 2. This is 9, remainder 1, and 16 is 8. So 2 and 98. I know it cannot be divided by 3. Why not? Because the divisibility rule for 3 is you add up the digits, and if the sum can be divided by 3, then that means the number can be divided by 3. But if I add up these digits here, I get 16. 16 cannot be divided by 3, so therefore, it cannot be divided by 3. But I know it can be divided by 4. All right, I know it can be divided by 4 because the last 2 digits, 96, can be divided by 4. So to find out the factor pair, I would have to go 196 divided by 4. 4 in 1 is 0. Put the 1 in 19. 4 in 19 is 4. Remainder 3. 4 in 36 is 9. Okay, good. So we have 4 and 49. All right. And if 49 is a factor, then we know 7 has to also be a factor, right? So we can use 7. 5 is not a factor, obviously. 6 is not a factor also, from the divisibility rules for 5 and 6, we know that they are not factors. So 7 and what though? 196 divided by 7. This would give me 2 remainder 5. in 56 we have 8, so the answer is 28. So 7 and 28. Let me clear out all of this space here. Okay, and then just by now considering, so the thing is that every factor of a factor would also be a factor. So let me put this down. So let's say I have okay, so let's say I have 30. 6 is a factor of 30, right? Since 6 is a factor of 30, every factor of 6, 2 and 3 automatically must also be a factor of 30. All right, so every factor of 6. So if I monitor this from this 28, intuitively you should know that 14 is also going to be a factor. And 14 is not exactly a factor pair because 14 squared is 196. Okay, but just by listing out the factors, I think, before we even got halfway, we probably could have eliminated all of the options. All right, and settled for E. Could have eliminated all of the options and settled for E. So the correct option is option E. All right, the prime factorization of 270 is let's use the technique for that just breaks it down. Okay, I call it the tree method. I find it easier, so we can just go 27 times 10 is 270. We can break down 27 into 9 times 3, and then break down 3 into 3 times 3. So I'll put circles around this because they are all prime numbers. And then 10 can be broken down into 2 and 5, prime numbers also. So the answer is 2 times 3 raised to the power of 3, because we have, and then times 5. So 2 times 3 raised to the power of 3 times 5, that's option B. Okay, factors of 6. All right, so let's use factor pairs. Factors of 6. I would say 1 and 6. 2 and 3. Okay, and nothing else. So 1, 2, 3, 6. That's option B. 58. The HCF of 13 and 39 is 13. All right, it's 13. And if you set it up, we can only divide by what can divide everything. So if I have 13 and 39, 13 can divide both of them. So I have 1 and 3. And so there's nothing else that can divide. So the HCF is just 13. The HCF is just 13. The highest common factor of 5, 7, and 17 is 1. Okay, and I'll explain. So if you try to set it up, you won't find anything that can divide through, right? So you might want to say that there's no HCF, all right? But when you think about it, 1 can divide all of them, all right? So 1 is a common factor to all numbers, right? So that means that 1 can divide all of them, and 1 is the highest because nothing else works. So the answer is actually 1. Okay, number 60, the highest common factor of 12, 30. So let me draw this out. 12, 30, 42, and 72. All right, so I can use 2. Can work with 2. Pick up 2. We have 6. We have 15. We have 21. We have 36. All right. 2 can't work for all of them anymore, so we can't use 2. Remember, we're doing highest common factor, so we use 3. 3 can work for everything, right? So we have 2, 5, 7, and 12. There's nothing else that can divide, so we just have 2 times 3, which is 6. So the HCF is 6. Highest common factor is 6. Okay. The LCM of 8, 12, 16, and 24 is, so the LCM of 8, 12, let me put this down here. The LCM of 8, 12, 16, and 24 is, okay, we start with 2, 4, 6, 8, 12. We can work with 2 again. 2, 3, 4, 12. We can work with 2 again. 1, 3, 2, 6. We can work with 2 again. 1, 3, 1, 3. And now we can work with 3, 1, 1, 1, 1. So it is LCM is 2 times 2 times 2 times 2 times 3. This is going to be 16 times 3, which gives you 48. The lowest common multiple of all of those numbers is 48. The LCM of 12, 8, and 4 divided by their HCF is, okay, so we need to find the LCM first, and then we now find the HCF, and then we can divide it. Okay, so what's the LCM? Let's do LCM. We have 12, 8, and 4. All right, so we can work with 2. 2 in 12 is 6, 2 in 8 is 4, 2 in 4 is 2. We can work with 2 again, we'll have 3, 2, 1. We can work with 2 again, we'll have 3, 1, 1. And we can work with 3, we'll have 1, 1, 1. So the LCM is 2 times 2 times 2 times 3. So LCM is going to be 2 times 2 is 4, 4 times 2 is 8, 8 times 3 is 24. So the LCM is 24. All right, so let's work HCF now. Highest common factor. Of 12, 8, and 4. For HCF, remember that we only divide by what can divide everything. All right, so we're going to use 2. We have 6, we have 4, we have 2, and I think 2 can divide everything again. So we have 3, 2, 1. All right, so HCF is 2 times 2, 4. HCF is 4, which implies that the LCM, so the LCM of these 3, which is 24, divided by their HCF, so divided by their HCF, which is 4, is basically saying 24 divided by 4, all right, which gives you 6. The answer is 6. That's E, option E. #63. The LCM of 13 and 39 is, all right, so the LCM of 13 and 39 is, we can start with 3 because 39 can be divided by 3, right? So we have 13 and 13. Then we use 13, we have 1, 1. So the LCM is just 3 times 13, which gives 39. 3 times 13, which gives 39. All right, that's 63. Okay, 64 says the LCM of two numbers is 60 and the HCF is 10. One of the numbers is 30. What is the other number? Okay, so the LCM of two numbers is, I think one of the things, since it's an option-based exam, right? You want to test with all of them. So the sum one of the numbers is 30. Let's start with the fact that the highest common factor is 10. That means that whatever number this is, both 10, whatever this number is, yes, 10 can divide it. 10 can divide the number and 10 can divide 30. All right, 10 is a factor of both of them. All right, so 10 is a factor of both numbers. So which means we can cancel out this, and this. all right? And then if the LCM is 60, that means that 60 is a multiple of both numbers. So look at the options. 60 is not a multiple of 40, so the answer has to be B, 20. All right. So 20 is 10 is a factor of 20, and 6 is a multiple of 20 20 also. Okay, what's the least common multiple of 50, 15, and 6? What's the least common multiple of 50, 15, and 6? Okay, so let's work this out. 50, 15, and 6. All right. So we can work with 2. We have 25. We have 15. That's we just put down 15. We have 6. That gives us 3. Next we use 3. We have 25. Then 3 and 15 is 5. And then 3 and 3 is 1. Okay, we can move to 5 now. So this will give you 5, 1. So this will give you 5 here, 1, 1. And we can finally use 5. We have 1, 1, 1. So the answer is 2 times 3 times 5 times 5. If I multiply from the back, 5 times 5 is 25. 25 times 3 is 75. 75 times 2 is 150. 150. So the answer is C. LCM is 150. Okay. Number L is a prime factor less than 10. The number L is also a factor of 42 and 45. All right, what is L? Okay, so for just the fact that it's a factor of 42 and 45, we already know that the answer is 3. All right, we already know that the answer is 3. So, because that's the only common factor of both of them. All right, and then it's a prime factor less than 10, so the answer is 3. Okay, so the prime numbers between 50 and 60. Okay, so let's list out all the prime numbers and use our divisibility rules to eliminate them. So I'll have to write around the all right, so let's take out the numbers that are composite. 50 is composite because can be divided. In fact, we can take out all the even numbers because they can all be divided by 2, right? Yeah, so we can just take out all of them. Now let's deal with the odd numbers. 51 can be divided by 3. Why? Because if you add up the digits, it gives you a value that is divisible by 3, right? So that means this is out of it. 53 cannot be divided by any other number. All right, 53 cannot be divided by any other number. So 53 is good. 55 can be divided by 5, right? You guessed it, 5. So this is obviously not among. 57 again can be divided by 3. 5 plus 7 is 12. So since 12 can be divided by 3, 57 can be divided by 3. So this is also out. So the only options that we have are 53 and 59. 59 cannot be divided by any other number. So the correct option is option A. All right, so the prime numbers between 60 and 70 are, so let's list them out. We have 60, 61, 62, 63, 64, 65, 66, 67, 68, 69, 70. All right, so let's eliminate the even numbers first because they cannot be divided by 2. All right, now the numbers that can be divided by 3. The rule for 3 is that if you add up the digits, if the sum is divisible by 3, then the number is itself also divisible by 3. So this doesn't work, all right, because 6 plus 3 is 9, all right. This also doesn't work because those two sum up to 15. Yeah, and 15 is divisible by 3. Okay, and 65 can be divided by 5. All right, so we have our winners. Our winners are 61 and 67. They are prime numbers, 61 and 67. What is the smallest number that can be divided exactly by 22, 44, and 55? Okay, so they're asking us for the LCM. 22. So we have 22, 44, and 55. I can work with 2. 2 in 22 is 11. 2 in 44 is 22. And then 2 in 55 doesn't work. Remember, we're finding the LCM, right? This basically means the LCM. The smallest number that all of them can, can divide without a remainder. That's the LCM. So 2 in 55, we just put down 55. We can still use 2. We have 11, 11, 55. Now we can use 5. We have 11, 11, 1. 11, 11, 11 rather. 11, 11, 11. And then we can now use 11, giving us 1, 1, 1. Okay, so the LCM is going to be 2 times 2 times 5 times 11. 20 times 11 is 220. It's 220. Okay, so what are the common factors of 15, 30, and 60? All right, so we want to list out, there are 2 ways to do this, right? Okay, rather, there's really just one way to do this. You just list out the factors and pick them out, all right, so that you don't miss anyone. So let's do factor pairs. Factor pairs of 15, I have 1 and 15. There's no 2, but I have 3 and 5. All right, and there's nothing in between. So these are the factor pairs. All right, then for 30, I'm going to have 1 and maybe 30. 1 and 30, no maybes, 1 and 30. I would have 2 and 15. I would have 3 and 10. I would have 5 and 6. Okay, 5 and 6. Finally, for 60, I would have 1 and 60, 2 and 30, 3 and 20, 4 and 15, 5 and 12, 6 and 10, okay, that's all. So let's pick out the prime. The common, right? We asked for common factors. So we have 1. All right, we have 1. We have 3. We have 5. And we have 15. So we have 1, 3, 5, 15. We don't have that option there, which shouldn't be, because 1 is actually included, right? 1 is a factor, and it is common to all of them. And the question is say what are the common prime factors? You say what are the factors? So I think the question is wrong, but we'll take the closest, in the answer, because again, it's an exam. You can argue later, but you have to take what you feel like the correct answer is, and that'll be 15. That'll be B rather, 3, 5, 15, yes. Okay. Question 71 is saying, what are the prime factors of 197? So we need to list out the factors of 197 and then figure out which ones. 195. Question 71 is saying, what are the prime factors of 195? Okay, so we need to list out the factors, of 195, and then now pick out which are prime. But alternatively, another way to do it is just test, the options, since we have options. And I think that would be an easier route, since we don't exactly, since the factors of 195, don't appear everywhere in, our multiplication tables and stuff. So we know 5 is a factor, obviously, because it passes the divisibility rule for 5. So we know 5 works. Amongst the options, we also have 3. And if you test the rule for 3, the rule for 3 states that if you add all the digits and the sum of the digits can be divided by 3, then the number is divisible by 3. So if you add the digits, if you add 1 plus 9 plus 5, you would get 15. All right. So since 15 is divisible by 3, then that means that 3 is also a factor, right? Then next we should try, so let's try 11. All right. So for 11, 7, 13, we don't have rules. So okay, so let's start with 7. 195 divided by 7, 7 in 1, 7 in 19, 2, remainder 4, 7 in 45, 7 in 55 rather, remainder 5, 7 in 55 doesn't work, 7 in 55 wouldn't work, so that means that 7 is not a factor, so we can rule out these two. All right, next we try 11. Let's try 11. 11, 195 divided by 11. 11 in 19 is 11 19 is 1 remainder 8. 11 in 85, that gives you 7 and the remainder, so remainder something, so it doesn't work, right? So it's not a factor. All right, finally let's try 13. 195, so we can cancel out this. So let's see if 13 is a part of it or if it's just again 5. 195 divided by 13. 13 in 19 is 1, remaining 6. 13 in 65 is 5. Okay, so 13 is correct. So the correct option is option E. Option E is the correct option. It is 3, 5, and 13 because these numbers can divide 195 and they're all prime numbers. Okay. All right, so let me quickly check back on 63 and 69 why we didn't put in answers, just to be sure. For 63, the answer was 39, so I remember we solved that. Then for 69, 69 at the bottom of the page, yeah, we solved this. The answer was 220. The answer was 220. So we solved that already. Okay. So let's just move on. Okay, so 72 says, what are the prime factors of 210? Prime factors of 210. So we can test the options. All right, we can test the options. We know that 2 works. All right, if you check the rule for 3, the rule for 3 states that if you add up all the digits, if the sum of the digits can be divided by 3, then that means the number can be divided by 3. So if you add up the digits, you have 2 plus 1 plus 0, that gives you 3. All right, so since 3 can be divided by 3, that means that 3 can divide 210. All right, so that's correct. 7, all right, so of course 7 works because 7 in 21 works, so 7 is also an option. Oh, I forgot 5 works because it ends with 0. Okay, so 2, 3, 5, 7. I think the only other number we need to test is 11. 11 wouldn't work. All right, we can just try dividing 210 by 11. Here would be 1 remainder or remaining 10. Okay, and 11 in 100 doesn't work. All right, so if I put the 10 here, it becomes 100. 11 in 100 doesn't work. So we have that question mark. So the answer is 2, 3, 5, and 7. 2, 3, 5, and 7. 2, 3, 5, and 7. Okay, so the next one is 73. It says, what is 13 squared? All right, what is 13 squared? So that just means 13 times 13, right? Is 169. All right, I mean, most of us should be familiar with this by now. 3 times 3 is 9. 3 times 1 is 3. Then we close up this space. 1 times 3 is 3. 1 times 1 is 1. So if I add up, I have 9, 6, 1. So 169. That's 13 squared. $45, 60, and 150. Okay, we are asked to find the highest common factor. So for highest common factor, we only divide by what can divide all of them, right? I know that 3 works. All right, so 3 in 45 gives me 15, 3 in 60 gives me 20, and then 3 in 150 gives me 50. All right, so 3 works. 2 doesn't work, obviously, that's why we use 3. But we can use 5. All right, so that would be 3, this would be 4, this would be 10. There's nothing else that can divide all of them, right? So we have just 3 times 5, which is 15. All right, 3 times 5, which is 15. All right, next is find the HCF of 18 and 36. Find the HCF of 18 and 36. Find the HCF of 18 and 36. All right, so again, we're going to be working, trying to find out, we'll be only using numbers that can divide all of them, right? So when we do HCF, we only use numbers that can divide all of them. So I can start with 2. 2 would give me 9. 2 would give me 18. 2 can't work anymore, right? The only number that can divide all of them now is 3. 3 in 9 gives me 3. 3 in 18 gives me 6. I can use 3 again. 3 in 3 gives me 1. 3 in 6 gives me 2. All right. So my HCF would be, HCF is going to be 2 times 3 times 3, which is 2 times 9, which is 18. HCF is 18. HCF is 18. All right, 76 is, what's the HCF of all of these numbers? Okay, so we'll just put them down and only divide by what can divide all of them. Yeah, we're only going to divide by what can divide all of them. So I'm going to list them out now. We have the HCF of all of these numbers. So let me list them out. We have 27, we have 15, we have 3, we have 21, and we have 9. Okay, so is there any number even that can divide all of them? Yes, 3 can divide all of them. So we have 9, 5, 1, 7, 3. All right, there's no other number that can divide all of them. So my HCF is just 3. It's just 3. That's option E. Okay, 77 says, what is the HCF of 18, 27, and 36? All right, so what's the HCF of 18, 27, and 36? All right, so we only divide by what can divide all of them. 2 cannot work for all of them, right, because of 27. So we're going to move to 3. 3 in 18 is 6. 3 in 27 is 9. 3 in 36 is 12. And I think 3 can divide all of them again. 3 in 6 is 2. 3 in 9 is 3. And then 3 in 12 is 4. All right, so there's no other number that can divide all of them. So our HCF, our highest common factor, is just 3 times 3, which gives us 9. So our highest common factor is 9. Okay, 78 says, what is the HCF of 9, 12, and 15? What is the HCF of 9, 12, and 15? All right, so let's draw it out. We have 9, 12, and 15. What could work that can divide everything? Just 3. All right, so we'd have 3, 4, 5. There's nothing else that can divide through, right? So we are done. For HCF, we only divide by what can divide all of them. All right, so there's nothing else that can divide all of them. So a HCF is simply equal to 3. That's option A here. That's option A. All right, 79 says, what is the LCM of 18, 28, and 84? 18, 28, and 84. All right, so 18, 28, and 84. All right, so for LCM, we're going to be dividing by what can divide any of them, and we divide all the way to 1 when everything becomes 1. All right, so we can start with 2, 9, 14, and 42. We can still work with 2. We'd have 9, 7, and 21. Now we can work with 3. We'd have 3, 7, and 7. We can work with 3 again. We'd have 1, 7, 7. All right, and then finally we can work with 7. We'd have 1, 1, 1. So our LCM is just going to be, LCM is going to be 2 times 2 times 3 times 3 times 7. So 2 times 2 is 4. 4 times 3 is 12. 12 times 3 is 36. So the answer is 36 times 7. That's 42. And then 7 times 3 is 21. 21 plus 4 is 25. So we have 252. 252 there. All right. So question 80 is, what is the LCM of 16 and 24? The LCM of 16 and 24. Okay, so we're going to be dividing all the way, right, until we get to 1, everything becomes 1 at the bottom. So 2 in 16 gives you 8, 2 in 24 gives you 12. We can work with 2 again. 2 in 8 gives you 4, 2 in 12 gives you 6. We can work with 2 again. 2 in 4 gives you 2, 2 in 6 gives you 3. 2 again, 1, 3, and finally 3 we have 1, 1. So our LCM is going to be 2 times 2 times 2 times 2 times 3. That will be 8 times 3, which gives me 24. The LCM is 20. Apologies, that would be 16 times 3. Thanks. 16 times 3. That's 16 times 3, which gives me 24. So, which gives me 48. Sorry, which gives me 48. Sorry, I've been solving 80 questions now. So, yeah. So that's 48. That's option B. Option B. Okay. All right. Okay, the next one is, what is the least number that can be divided exactly by 5? Exactly by 5, 7, and 9. Exactly by 5, 7, and 9. What is the least number that can be divided by 5, 7, and 9? Okay, so what can we use? 2 wouldn't work. All right, so we could use 3. Would have, let me pause for a bit, right? The least number that can be divided by all of them is basically the LCM. All right, that's the least common multiple of all of them. So that's what we're doing. Okay, so 3 in 5 doesn't go, so we put down 5. 3 in 7 doesn't go, we put down 7. 3 in 9 is 3. Next, 3 in 5 doesn't work, we put down 5. 3 in 7 doesn't work, we put down 7. 3 in 3 is 1. Next, we can work with 5. We have 1, 7, 1. And then finally 7 would have 1, 1, 1. So my LCM is 3 times 3 times 5 times 7. All right, so I'll multiply backwards. 7 times 3 is, I'll multiply from the back rather. Yes, 7 times 3 is 35. 35 times 3 is 105. 105 times 3 is 315. 315. So the correct option is E, 315. All right. What is the lowest number that can be divided by 3, 8, and 10 without a remainder? Again, this is just another way of asking for the LCM, right? The LCM. So what's the number that divided by 3 of them without the remainder? So if I put this down here, 3, 8, and 10, I can use 2. I would have 3, 4, and 5. I can use 2 again. I would have 3, 2, and 5. I can use 2 again. I will have 3, 1, and 5. Now I can work with 3. I would have 1, 1, 5. And finally, I can work with 5. And I'll have 1, 1, 1. So the lowest number that can be divided by all of them is the product of all of them. Is just my LCM is just 2 times 2 times 2 times 3 times 5. That's 8. 2 times 2 times 3 is 8. Okay, so 8 times 3 is 24. 24 times 5 is 120. 120. That's option B. All right. We're asked to find the product of the LCM and HCF of the number. So we'll find the LCM first, and then we'll find the HCF. We'll multiply them together, right? You need to find the LCM first. You get that. Find the HCF, get that, and then you multiply it together. The LCM of 12, 9, and 15. So let's do LCM first. 12, 9, and 15. All right, so I would use 2. 2 in 12 is 6. Then we bring down 9. And then 2 in 15, we just write 15 because 2 can go into, 9 and 15, yeah? Next, we use 2 again, and we'll have 3. We bring down 9, 15. All right, so nothing can be divided by 2 anymore, so we have to pick up 3. All right, so 3 in 3 is 1, 3, 5. We pick up 3 again, 1, 1, 5. And finally, we pick up 5. We have 1, 1, 1. So our LCM is 2 times 2 times 3 times 3 times 5. This is 4, 12, 36, 118. All right, so the LCM is 118. All right, next we pick up on the HCF. For HCF, we divide by only what can divide everything, right? So we're just trying to get, is there anything that can divide everything, and then we'll use that. We have 12, 9, and 15. 12, 9, and 15. The only number that can divide all of them is 3. We'd have 4, 3, 5. There's nothing else. So our HCF is just what? It's just 3. Right? Our HCF is 3. So when they say what is the product of the LCM and the HCF, we just do what is the product of 180 and 3, which gives us 540. All right, 540. All right, 84. What's the product of the LCM and HCF of this numbers? Very good. So we start all over again. We have LCM. The LCM of 6, 8, and 12. The LCM of 6, 8, and 12. Okay, so I guess we'll pick up with 2. 2 in 6 is 3. 2 in 8 is 4. 2 in 12 is 6. We can still use 2. We'd have 3, 2, 3. We'll pick up 2, we have 3, 1, 3. We'll pick up 3, we have 1, 1, 1. All right, so the LCM is just 2 times 2 times 2 times 3. That's 8 times 3, that's 24. So the LCM is 24. Then for the HCF, we only divide by what can divide all of them, yeah? We will only be dividing by what can divide all of them. So we have 6, 8, 12. What can divide all of them? We know 2 can. We'll have 3, 4, and 6. All right, so there's nothing that can divide all of them anymore apart from 2. All right, so our HCF is just what? Is just 2. All right, so HCF is 2 and the LCM was 24. What's the product? So if we go back to the question, we just need to do 24 times 2, which is 48. 24 times 2, which is 48. All right. What is the smallest number that can be divided exactly by 6, 7, and 9? That can be divided. So it's basically saying what is the LCM, right? The smallest number that can be divided by all of those is the least common multiple. All right. So we have 6. We have 6. We have 6, 7, and 9. All right, we can use 2. All right, we can use 2 to find the LCM. So we start with 2. We have 3, 7, 9. I can use 3. I can't use 2 anymore. So 3 will give me 1, 7, 3. I can use 3 again. I would have 1, 7, 1. And finally 7 to give me 1, 1, 1. All right, so the smallest number, the LCM of all of those, is just 2 times 3 times 3 times 7. That would be 7 times 3 is 21. 21 times 3 is 63. And 63 times 2 is 126. All right, so the LCM is 126. Next question says, what is the smallest number that can be divided by 3, 9, or 12 without a remainder? What's the smallest number that can be divided by 3, 9, or 12 without a remainder? All right, so we can use basically smallest number that can be divided by all of those is just asking for the LCM, right? Because that number has to be a multiple of all of them, and the smallest one, which is where the least come from, so least common multiple. Perfect. All right, so so to find the LCM, we start with 2, because 2 can divide 9. So we have 3, 9, 6. We can go with 2 again, right? Because 2 can still divide 6. So we have 3, 3, 3, 9, 3. My bad. So we have 3, 9, 3. Because 2 can't divide 9, so just bring it down. And then 2 and 6 is 3. Now we use 3. We have 1, 3, 1. And then we can use 3 again, and we'll have 1, 1, 1. All right, so the LCM would just be 2 times 2 times 3 times 3. That would be 4 times 9, which is 36. So the LCM is 36. All right, what's the smallest number that can be divided by 2 and 3? If you know your multiplication tables, all right, you just know the answer is 6. You don't really have to do any. I mean, you can do LCM and all of that. So let's do that, but we don't have to. All right, it's 6. Because I mean 2 and 3. We can use 2, so 1, 3. And now we can use 3. We have 1, 1. So the answer is just 2 times 3, which is 6, right? That's the LCM. The LCM is 6. Right, question 88. What is the smallest number that can be divided exactly by 3, 5, and 7? 3, 5, and 7. What's the smallest number that can be divided by 3, 5, and 7? All right, so it's LCM. So let's begin. We can use 3, right? We'd have 1, 3, and 5. Doesn't work, so put on 5. And then 7. We can use 5. 1, 1, 7. And finally, we use 7. We have 1, 1, 1. All right, so the LCM is 3 times 5 times 7, which is 105. 105. That option is option D. Okay, 89. What is the smallest number that can be divided by exactly 3, 7, and 9? Okay. So it's still LCM. But I feel like some of this, well, depending on how familiar you are with your multiplication tables, you should be able to just, so you can pause and maybe look at the answer and just think about it. If you know your tables, that is, but if you don't, it wouldn't work. So 3, 7, and 9. All right, so we can work with 3. Oh, give me 1, 7, 3. We can work with 3 again, 1, 7, 1. And we can work with 7, we get 1, 1, 1. So it's just LCM is 3 times 3 times 7, which is 9 times 7, which is 63. 63, that's option C. Question 90 says, what's the smallest number that can be divided exactly by 5, 7, and 9? Smallest number that can be divided by 5, 7, and 9. All right, so we can use, it's LCM, right? What is the smallest number that can be divided exactly by that? Is asking you for the LCM. We can start with 3. 3 and 5, no, doesn't work, so we'll put down 5. 3 and 7 doesn't work, put down 7. 3 and 9 is 3. All right, we can still use 3 because of the 3 we have, in the last column. So we can use 3 again. Work with 3, we have, bring down 5, bring down 7, and then 1, and we can't use 3 anymore. So the next prime number we can use is 5. We have 1, 7, and the final prime number we'll use is 7, 1, 1, 1. Sorry. So that means the LCM is 3 times 3 times 5 times 7, which would be 315. All right, because 7 times 5 is 35. 35 times 5 is 1. 35 times 3 rather. Let me go again. 7 times 5 is 35. Times 3 is 105. Then times 3 again is 315. Yes, so 315 is correct. All right, so sorry, 75, question 75 is unanswered. So let me just check. Then we'll come back to 90, 75. Sure, we solved it. HCF, okay, we solved this. The answer was 18. Okay, so we can go back to 91 now. And 75 is answered. Good. All right, what's the smallest number that can be divided exactly by that? Which means they're asking us for the LCM. We're being asked for the LCM. So we have 24, 32, and 40. All right, what can we use? We can use 2, right? 2 in that will give me 12, 16, and 20. We can use 2 again, would have 6, 8, and 10. We can use 2 again, would have 3, 4, and 5. We can use 2 again, would have 3, 2, and 5. We can use 2 again, would have, we'll bring down 3, 1, and 5. Okay, good. So now we have to use 3. We have 1, 1, 5, and then finally 5. We have 1, 1, 1. So our answer is 2 times 2 times 2 times 2 times 2. That's 5 2s, right? And times 3 times 5. Okay. So 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16, 16 times 2 is 32. All right, 32 times 3 is 96, and 96 times 5 is 418. So the correct option is B, option B. All right, for question 70, it says, what is the smallest number that has a remainder of 2 when it's divided by 6, 7, or 8? Good. So that means we need to find the LCM, all right, because the smallest number that can be divided by 6, 7, or 8 is actually the LCM. You find the LCM, but then you add the remainder 2 on it, all right, to give you the number that would, that would fit this this narrative, all right, this narrative. Yeah. So let's find the LCM first, and when we're done, we add on our 2. 6, 7, 8. Okay, so we can begin with 2. 2 in 6 is 3. 2 in 7 doesn't work. 2 in 8 is 4. We can work with 2 again, and doesn't work. 3 doesn't work. 7 works. 2. Good. We can use 2 one more time, so we'd have 3, 7, 1. Now we can use 3. We'll have 1, 7, 1, and finally 7 would have 1, 1, 1. So the answer to this is the LCM, all right, would be 2 times 2 times 2 times 3 times 7, which would be 7 times 3 is 21, 21 times 2 is 42, 42 times 2 is 84, 84 times 2 is 168. Yes, 168. All right, so that's the LCM, but then remember the remainder of 2, all right, because we wanted to have a remainder of 2 each time. So the solution will be 168 plus that remainder that we always want to have, which gives us 170. 170, that's option B. All right, what is the smallest number that has 6, 8, and 12 as factors? All right, so we could actually answer this without, solving for the LCM, even though this is just another creative way to ask for the LCM, right? But we could do this. If you know your multiplication tables, you can get the factors, and 48 does have all of them as factors, but 48 is not the smallest. The smallest is 24. All right, but I'll still just do the LCM thingy, just so we see that also works. So it's the smallest number. The LCM is the smallest number that all of this can divide, or same thing, that all of these are a factor of. All right, so we have 6, 8, and 12. We can work with 2. We'll have 3, 4, 6. We can work with 2 again. We'll have 3, 2. We'll have 3, 2, 3. We can work with 2. We have 3, 1, 3. We can work with 3. We have 1, 1, 1. So our LCM is just 2 times 2 times 2 times 3, which is 8 times 3, which is 24. 8 times 3, which is 24. Okay, 95 says, what is the square of 2 pi root a? All right, so 2 pi square root of a. What is the square of the whole thing? Okay, so we'll just we can apply the square to each individual factor. Would have 2 squared times pi squared times root a squared. Okay, so this would be 4. Pi squared is pi squared, and then root a squared will just give you a. Okay, so square cancels out square root, so root a squared will just give you a. So you have 4 pi squared a. That's option B. 4 pi squared a. That's option B. Okay, question 96 says, what is the square root of 625? What is the square root of 625? Okay, so we can use the factor method, right? We can use the factor method. 625, so it can be divided by 5. 5 is a factor, so 5 in 625 gives you 125. We can use 5 again. 5 in 125 gives you 25. We can use 5 again. 5 in 25 gives you 5, and then 5 in 5 gives you 1. So we pick them up in pairs. We pick them up in pairs. So I pick up this 2 as 5. All right, so pick up the 5 and 5. Just take one of the pair, each pair, right? Have 5, and then take the second one and take this as 5. And we multiply. Okay, so we multiply all the pairs we could, all the numbers we could pick out of each group. All right, so that will just be 5 times 5, which is 25. Okay, you can go on to test the answer. You can try multiplying 25 by 25 and see if it gives you 625. Okay, that's that for that question. We'll move on to what is the square root of that? Okay, so what is the square root of? We have 9 over 16 m squared t squared. I will need to find the square root of the whole thing. All right, so this will just be the square root of 9 over 16 times the square root of m squared times the square root of t squared. All right, so the square root of 9 over 16, we could redo this as just apply the square to the square root sign to the top and the bottom. All right, so that would give me 3 out of 4 times, well, the square root of m squared would just be m, right? Because square root cancels out square. And then the square root of t squared would just be t. We'd end up with 3 over 4 mt. 3 over 4, 4 mt. Okay, so question 98 says, what is the value of 2 raised to the power of 3 times 3 raised to the power of 2 times 7? All right, so that's 2 raised to the power of 3 times 3 raised to the power of 2 times 7. That would be 8 times 9 times 7, okay? 2 raised to the power of 3 is 2 times 2 times 2, which is 8. 3 raised to the power of 2 is 3 times 3, which is 9, so times 7. So we'll have, well, we could play it as 72 times 7. So I'll come over here and do the math. 72 times 7 gives us 14. Put 1 up. 7 times 7 is 49. Plus 1 is 50. So we have 504. 504, that's option B. Good. All right, so question 99, right before the big 100, we have what is the value of 2 squared times 3 squared times 5? What's the value of 2 squared times 3 squared times 5? So 2 squared gives 4 times 3 squared gives 9 and 5. So that will be 36 times 5, which gives 180. All right, so the final answer is 180. 180. All right, so for question 100, it says, what is the value of 2 cubed times 3 squared times 7? All right, so 2 cubed is going to be 8 times 3 squared is going to be 9, and then times 7. So that would be 72 times 7. We can work that out here. 72 times 7. 7 times 2 is 14, carry 1. 7 times 7 is 49 plus 1, 50. So the correct answer for that is 504. 504. Okay, 101. Which of the following gives all the prime numbers between 0 and 7? Which of the following gives all the prime numbers between 0 and 7? Okay, so let's list them all out, and then we'll just pick out the ones that are prime. So we have 1, 2, 3, 4, 5, 6. Okay, so interestingly, right, if they say between 0 and 7, I mean, I think it should include 7 and 0, right? But let's see how that goes. So I won't include them for now, and then when we look at the options, we'll now know, probably will have more insight to exactly, what the answer, or if they included 0 and 7. Okay, but I know for one that 1 is not a prime number, all right? Because if every prime number must have 2 factors, 1 and itself. 1 has only itself as a factor, so 1 is not a prime number. 2 is a prime number because the factors are only 1 and 2. 3 is a prime number because the factors are only 1 and 3. 4 is not a prime number, all right, because it has the extra factor of 2. 5 is a prime number, all right, because it can only be divided by 1 and 5. 6 is not, because it can be divided by 2 and 3. So the correct answer should be 2, 3, and 5. Okay, but looking at the options now, it's obvious that they included, when they said between 0 and 7, they included 0 and 7. So I've included 0 and 7 now, and I'll just look at it and see. So going back, 0 is not a prime number, all right, because 0 is, every number can divide 0, you just get 0, right? So, but you need only 2 factors. But 7 is a prime number, right? So if I add 7 to the list, then that makes option C the correct choice. Option C is the correct choice. All right, question 102. Question 102. Which of the following gives the prime factors of 60? Okay, so we can get out the factors of 60 and then check which ones are prime. So 60, we use factor pairs. So we'll list out the factors in pairs. We have 1 and 60. We have 2 and 30. We have 3 and 10. No, 3 and 20, sorry. I know 4 is a factor, so 4 and 15. 5 and 12. 6 and 10. Wow, has a lot of factors. All right, so 6 and 10. So let's look at the ones that are now prime. All right, 1 is not prime. All right, because for it to be a prime number, the number must have only 2 factors, but 1 has only 1 factor itself. All right, but prime numbers should have 2 factors. All prime numbers must have 2 factors themselves. All right. 2 has 2 factors, 3 has 2 factors, 4 has more than 2 because 2 is an additional factor, 5 has 2 factors, 6, nope, 10, nope, 12, nope, 15. Okay, so I guess the answer we have is just 2, 3, and 5. That's option B. 2, 3, and 5. Okay, which of the following is a perfect square? Oh, that's easy. From a multiplication tables, you should know that 121 is 11 times 11, right? So the rest are not perfect squares, not by any count. All right, so that's for question 103. For question 104 says, which of them is a prime number? Prime numbers are numbers that can only be divided by 1 on themselves. All right, so let's look at the options. 4 is not a prime number because 4 can be divided by 2. 8 is not. 8 can be divided by 2 and 4. 9 is not. 9 can be divided by 3. 6 is not. 6 can be divided by 2 and 3. 5 is the correct option because 5 can be divided by only 1 and itself. All right. Question 105. Which of the following is equal to 5 squared times 3 times 2 cubed? Okay, so we can just, multiply that out. That will be 5 squared times 3 times 2 cubed. That will be 25 times 3 times 8. That will be 25 times 24. All right, so let's do that. 25 times 24. 0, 2, 10. All right, we'll put this there, and then we'll just have 0 and 5. All right, and 10 carry 1 5, so that's just 600. Okay, so the answer is 600. 25 times 24 is 600. The correct option is option C. Okay, that's question 105. Question 106. Which of the following is equal to? Which of the following is equal to 3 squared times 5 times 2 cubed? All right, which of the following is equal to that? So this is 9. 9 times 5 times 8. So this will be 45 times 8. 45 times 8. 40 carry 4. 32. 32 plus 4 is 36. So we have 360. That's option A. Option A. Okay. Question 107 says, which of the following is equal to 120? And we have all the options in index form. So the easiest thing to do is to convert 120 to index form, and then we can now compare. All right. So in fact, instead of using this regular prime factorization method, let's just use the tree method, right? Where we just branch out from 120. I think that's easier. And we can break this, well, in many ways, but I'll just break it into 12 times 10. I think that's most obvious. Then we can break 12 into 3 times 4. All right. And then 4 into what? 2 times 2. So we can circle them when they become prime numbers. 10 can be broken into 2 times 5. All right. So we're done. If you look at what we have circled here, we have 2 raised to the power of 3, because we have 2, in 3 places. Then times 3 times 5. 2 raised to the power of 3 times 3 times 5. That is option E. Okay, this says, which of the following is equal to 60? To 60. So we just need to rewrite 60 in index, prime factorization. 60 can be split. So let's split 60 into 10 times 6. 10 can be split into 2 times 5. So I can circle that. And then 6 can be split into 2 times 3. Okay, so that means that the answer is 2 raised to the power of 2 times 3 times 5. Okay, 2 raised to the power of 2 because we have 2 twice, and then times 3 and then times 5. So those are all the prime factors we have. That option is option C. Okay. Question 109. Which of the following is not a perfect square? Which of the following is not a perfect square? Okay, so 15 is not a perfect square because there's no number that you'd square to get 15, right? 16 is a perfect square, that's 4 squared. 9 is a perfect square, that's 3 squared. 25 is 5 squared, and 4 is 2 squared. So the correct option is 15. 15 is not a perfect square. All right, 15 is not a perfect square. All right, 110. Which of the following is not a prime number? Okay. So a prime number is a number that can be divided by only 1 on itself. It has no other factors. All right, so that is 9, because 9 is not a prime number because 9 can be divided by 3. All right, but if we check out the others, 7 can only be divided by 1 and 7. 2 can only be divided by 1 and 2. 5 can only be divided by 1 and 5. 3 can only be divided by 1 and 3. So the correct answer here is 9. 9 is not a prime number. Okay. Which of the following is the LCM of 4, 10, and 6? Which of the following is the LCM of 4, 10, and 6? Okay, so 4, 10, and 6. All right, so when we do LCM, we divide by anything that can divide any of them, right? And we divide until we get to, the base form 1, 1, 1. All right, so let's go. 2 in 4 is 2, 5, 3. We can use 2 again. 2 in 2 is 1, but this would give 5, 3 because 2 can, divide them. And we'll move on to 3, 1, 5, 1, and finally 5, we have 1, 1, 1. So the LCM, we just multiply the factors. We have 2 times 2 times 3 times 5. So the LCM is, Okay, let me multiply. This gives me 15, this gives me 30, this gives me 60. All right, so it's 60. The lowest common multiple is 60. The smallest number that all of this can divide is 60. Okay. Which of the following is the least common multiple of 6, 5, and 4? Which of the following is the least common multiple of 6, 5, and 4? All right, so when we're trying to find the least common multiple, the LCM, what we do is we divide by what can divide any of them. All right, and we do that until everything reduces to 1, 1, 1. So like now I think we can work with 2. So we have 3. We write 5 because 2 can divide 5, and then we have 2. We divide again, we can use 2. We have 3, 5, 1. Then we divide by 3, we have 1, 5, 1. And then finally we divide by 5 and we have 1, 1, 1. So the LCM would just be 2 times 2 times 3 times 5. 2 times 2 times 3 times 5 would be 4 times 3 times 5, which would be 60. All right, that's 6, that's 12 times 5, that's 60. So the correct option is option E. All right, so which of the following numbers between 20 and 50 are multiples of 9? Okay, so we probably just want to look at the 9 times table and see what products fall within 20 and 50. So we should have 27. After 27, we should have 36 and then 45. All right, we can't go beyond 50, so we can move on to 54. That option is option A. Option A. Which of these numbers is not a perfect square? Not a perfect square. Okay, so 25 is a perfect square. Nope, 200 is not a perfect square. That's the correct answer. 200 is not a perfect square. And it's because there's no number you can multiply by itself to give you 200. All right. And this is also, if you're familiar with your multiplication tables, I think this question is just is a giveaway, and because you would know that all the others are perfect squares. All right. So like this is 5 squared, this is 3 squared, this is 1, 2, 1. Sorry, 1, 2, 1 is 11 squared. 1, 2, 1 is 11 squared, and 144 of course is 12 squared. So this is the only one that doesn't have a perfect a square root, and it's not a perfect square. Okay, moving on. 115 says, which of the following represents the prime factors of 130? Okay, so I know we have, if I try to list out the factors of 130, I would have 1 and 130. I would have 2, because it's an even number. When you divide that, you find out that it's 265. We also know 5, all right, and 5 and 13. Okay, so which ones are prime? 1 is not prime. 2 is prime, because it can be divided by only 1 and itself. 5 is prime. 13 is prime. Okay, so these 3 numbers can only be divided by 1 and themselves. 65 is a multiple of 5, so it's not. And then 130, of course, gave birth to all these babies, so it cannot have, or it cannot be a prime number. So the answer is 2, 5, and 13. That's option E. All right, which of the following represents the prime factors of 30? All right, so we're going to list out the factors of 30. 1 and 30, 2 and 15, 3 and 10, 5 and 6. Okay, so that's perfect. All right, so which ones are prime? 1 is not a prime number. 2 is prime, 3 is prime, 5 is prime. Okay, so these are all prime numbers because they can only be divided by 1 and themselves. 6 is not prime. 6 can be divided by 2 and 3. 10 is not prime. 2 and 5 can divide 10. 15 is not prime, and of course 30 is not prime. So the correct answer is option B, 2, 3, and 5. 2, 3, and 5. Okay, question 117 says, which of the following sets of numbers, in options A to E, I believe, gives all the prime numbers between 0 and 7? Okay, I think we've answered this somewhere before. Between 0 and 7. We have, between 0 and 7, we have 1, 2, 3, 4, 5, 6. All right, and the prime numbers there, 1 is not a prime number, 2 is a prime number, 3 is a prime number, 4 is not a prime number, 5 is a prime number, 6 is not a prime number. So the correct answer should be 2, 3, and 5. Okay, so but we don't have that option, and I think that's because when they set the questions, when they said between 0 and 7, I guess they included 0 and 7. All right, in between 0 and 7. If you add that, 0 is not a prime number. All right, because I mean 0 can divide every number, just like you get 0 each time though, but you know you can divide, 0 can be divided by every number. 7 is a prime number, all right, so we can add 7 to the group, and that makes the correct answer option C. Option C. Okay, 118 says, which of these numbers is not a prime number? Which of these numbers is not a prime number? All right, so 2 is a prime number, can only be divided by 1 and itself. 5 is a prime number, can only be divided by 1 and itself. 7 is a prime number. 13 is a prime number. 27 is not a prime number. It's not a prime number because 3 and 9 can divide, 27, right? So it has multiple factors as opposed to just 2. Okay, so that's for number 118. For question 119, which of these is a perfect cube? Which of these is a perfect cube? Okay, so the correct option is 8, because 2 times 2 times 2 gives you 8. All right, so that's 2 cube is 8. Okay, but that doesn't exist for the rest of them. I mean, 1 is a square, so you could say that's 9 squared. All right, 25 is a square also, that's 5 squared. 16 is a square, that's 4 squared, and then 36 is a square, that's 6 squared. But 8 is a cube. All right, 2 times 2 times 2, which is 8, gives a perfect cube there. All right, question 120. Which of these numbers is a perfect cube? Okay, so the correct option here is 216, right? Because 6 times 6 times 6 gives you 216. All right, but you might not have known that, just like maybe you're not that familiar with numbers yet, and it's very understandable. All right, but we can eliminate options. For instance, we know that 7 times 7 gives 49, so there is no way, that it's going to be a cube, because 7 is even a prime number, right? So there's no way it can work. 12 times 12 gives 144. 3 times 3 gives 9. So I mean, these are all squares, they're not cubes. All right, but just to be doubly sure, right, let's look at the prime factorization of 216 and see if we can find the cube root of that. So 216, the cube root of 216 would be, we have to do the prime factorization first, so I'll start with 2. If I work with 2, I'll have 1, 0, 8. I can use 2 again, I would have 5, 4. I can use 2 again, I would have 27. Now I can use 3, I would have 9. Use 3, I would have 3. Use 3, I would have 1. now I would need to pick out, you know, in groups of 3 again, because I'm trying to find the cube root, right? To confirm that it actually has a cube root. So I'll have 2 and I would have 3. So you multiply them out, you would have 2 times 3 giving you what? Giving you 6. So the cube root is 6. All right, so it does exist. So the correct option here is option B. Okay, finally, the last question says write 4,200 in index form. So I'll use the tree method I always use. 4,200 in index form. I can split this into 42 times 100. Then I can further split 42 into 6 times 7. 7 is a prime number, so I can circle that. But 6 has to be split into 2 times 3. All right, so 2 and 3 are prime numbers, so I can circle those also. I can split 100 into 10 times 10. Split 10 into 2 times 5. And then the other 10 also into 2 times 5. So that gives me all the prime numbers that I need. Everything has been broken down into prime numbers. So I have 2 times 2 times 2 times 3 times 5 times 5 times 7. All right, so that's 2 times 2 times 2, then times 5 times 5. Oh, times 3. Yeah, okay, so 2 times 2 times 2 times 3, then times 5 times 5 times 7. So I was just checking that I was right. All right, so this gives me 2 raised to the power of 3 times 3 times 5 to the power of 2 times 7. All right, and that option is option E, I believe. Option E, I believe. Okay, and we're done. Let's check. Okay, we left 2 questions on answers. Oh, 3 on answer 3. So let's go to 119 rather, and see why that question is unanswered. I think I just skipped it. Okay, yes, so we answered that it is C. C is a perfect cube. Question 91. Okay, the smallest number that can be divided by 4, 6, and 9. Okay, we did this. The answer was 36. Yes, was 36. And then 96. What is the square root of that? We did this and it was 25. Okay, so I guess we can finish our attempts now.